Hi guys, welcome back to my channel. Welcome back to yet another video. So today's video is going to be on graphs and how exactly is the graphs topic inculcated into the IBDP syllabus. So I'll be starting with what exactly is a graph first. So a graph is a structure which shows the physical connections or relationships between the things of interest. So this video will be going into the context of me talking about some key points and key terms first of all, and then we'll be looking at some questions. So the first few key terms that I'll be discussing is dots. So dots or points, are the areas of interest or the things of interest, whereas the lines are the connections or relationships between them. For example, the graph that we see over here shows the road of connections between the several towns and the airport which serves them. So you guys can see right over here itself that how a link or there is like a relationship or a connection between the airport and the town, which is called the line, and this itself is called the point. These all are points, right? All of them. So we can see that A and C are directly connected by the road, which means, let me just raise this for a better, clearer understanding. Yeah, now let's talk about it. So we can see over here that A and C are directly connected by a road, this one. But towns C and F, which is this one and this one, are not connected directly through the road. There is no road directly connecting them over here. So that's why this is not connected. Only A and C, airport and A, airport and B, B and D, D to C, etc. are all connected, whereas C to F is not connected. Let's move forward now. Now the other key terms or the terminologies that we need to know is going to include the first one, which is called vertex or vertices. So all of these points are rather called vertex and vertices. Vertex is the singular, vertices can be the plural. So all of these that I've marked are vertices, right? Now if we have to move from one vertex to another vertex, we will have the lines that we talked about. For example, this one, to move from the vertex A to vertex B, we have a line which is going to connect it called the edge. So all of these which are connecting each other, all of these are all edges, right? So when a different terminology, which is a little bit more complex than the ones we just studied right now, it is called the loop. So what is a loop, first of all? So when an edge from a vertex will, what's gonna really happen. For example, you can see this E is encircled, hence it means it's a loop. Okay, because an edge from a vertex to itself. Hence E is a loop and the rest of them are not loops. The next topic we have, or subtopic or key term that we have, is undirected graphs. So what exactly is undirected graphs, first of all? So if we are allowed to move in either direction along the edges of a graph, the graph is undirected. Okay, that means if we can move in either direction, so we can move towards F to A, we can move from A to F. We can move in any of the directions. So that's a undirected graph. Now, moving forward, adjacent vertices is another key term under undirected graphs. So undirected graphs have adjacent vertices. It can have, so adjacent vertices are vertices which are connected by an edge. For example, you guys can see A and B are adjacent vertices because they're connected by just one particular edge. Here you guys can see that. But D and F are not adjacent vertices because we can see that there is no connection, though no line, or rather no edge in between them. Next comes adjacent edges. So when I talk about adjacent edges, they are really the edges that share common vertices. For example, A, B and B, E are adjacent vertices, adjacent edges because they have the same vertex. This one and this one have the same vertex B, which means they are adjacent edges. But AB and CD are not. AB and CD, they are not because they aren't having the same particular vertex. They don't have the common vertex. The next one that we will be talking about is called the degree. So the degree of a vertex is the number of edges it's connected to. Okay, let me just wrap this all to explain this now. Okay, so right. So for example, if I have to talk about the degree of A, it will be 2 because it's connected to two different edges, 1 and 2. That's all. So it has 2. Let's take E. E has how many? E would have 3 because 1, 2 and 3, right? If I talk about C, C would now have 4 because a loop contributes to 2. So, I mean, this is 2 itself. So, this is when this is 2 itself, 2 plus 1, 3 and 1 more, 4. That means it has 4 degree at C because of the loop, which is the contribution of 2 degrees, right? Plus the actual ones like this and this. Let's move forward now. Next, we have the directed graph. Now, in the directed graph, it tells you if you can only go in one direction or you can go in the both directions. It lets you know about that. So a directed graph contains the arrows which indicate the direction in which we can move along the edges. If either we can move in one direction or we can move in both directions. It lets you know about that. So in a directed graph, we will have the in degree vertex. So the in degree of a vertex is the number of edges which are coming in towards it. I'll just explain that to you. You guys can see, let's talk about A for now. If I talk about A, this is coming towards A, but this is going away from A. So we have 1 in degree for A, whereas the out degree for A would again be 1 because it's the number of edges which are going out from the vertex. We can see that over here. We can see that over here how only 1 is going out. So the out is also 1 and in is also 1 because we have only 1 coming in as well. So if I now talk about, let's take another coordinate, another point itself so that we can understand in and out better. For example, if I take B, let's take B. For B, we have how many ins in degree? We have 1, 2, 3, right? So in degree for B is 3. Let's talk about the out degree now. The out degree for B is 1, 2, 3. So out degree is also 3. Doesn't have to be that they will have it same. For example, if I take for, let's say, C. If I take it for C, what will it be? For C, we have here, in degree will be 2, 1 and 2. Out degree will only be 1, right? So now let's move to some questions to understand the concepts better. So the first question is, state the number of vertices and edges in the graph. So we have 1, 2, 3, 4, 5, and 6 vertices. So I'll just write that down here. And edges, how many edges do we have? So we have here 1, 2, 3, 4, and 5. So we have 5 edges. Edges is 5. Sorry. So now the next question, it says, name the vertices adjacent to A. Right, so now what do we mean by vertices which are adjacent to A? Vertices which are adjacent to A would include, so for the A, we will have, this is A, so the vertex adjacent to the vertices, so this will be AB and BE, because these two are adjacent in here, right? So we made a mistake in understanding the concept when I was talking about the number of edges in the graph. It's again 6 because 1, 2, 3, 4, 5, 6, 7. That makes it 7. 1, 2, 3, 4, 5, 6, 7. Yeah, that's gonna be 7 instead of 5. I'm sorry if I made you guys confused, but that was a error. Anyways, let's continue with the things that we were doing. So we have the adjacent vertices to A will be AE and AB. Now talking about the adjacent vertices to D. For D, we will have DB, DE, and DF. Let's move forward. We would have name the edges adjacent to CE. So we have CE here. So this will be EF because they both share the same vertex. And for DF, we will have FE because F is the common vertex in that. State the degree of each vertex. So I won't state it for each, or we can state it for each as well. Let's just quickly do that for every one. I'll just write it down near it. So for A, the degree of vertex A would be 2, because 1 and 2. For B, it will be 1, 2, and 3 and 4. So that will be 4. C, it will be 1. D, it will be 1, 2, 3. For E, it will be 1, 2, 3, 4. For F, it will be 1 and 2. So that's, I hope you guys understood that. And let's do one last question to make this topic entirely clear. This one is majorly about vertex in degree and out degree. So we'll quickly do a few. I'll just mark which ones we're doing. We're doing P, we're doing S, and U, right? We'll do all of these. So, and rest this one, and this one. I would love you guys to do it. And let me know if you guys understood in the comment section. So this is for you guys to do. Let me now answer these with you guys right now. P, the int degree is 1 because only 1 is coming in. Out degree for P is 1, 2. That makes it a 2 out degree. For S, the in degree is 1. And yeah, that's it. 1. Out degree is also 1. For U, let's talk about U now. Just erase this to make the document clear. Alright, so for U, the in degree is 1. Out degree is 1. And no, in degree is for U 2, because you guys can see that there are 1. Okay, let me just do that again for you guys so that you guys don't get confused. So for the U, we have one coming in from here and one from here, that makes it 2. But for the out degree, we just have one going back, so it becomes 1 over here. How do you get from S to R? So you have to make a big way to get to from S to R. You'll have to explain this like you go from S to T, T to P, P to Q, and Q to R. So that's how which motion you have to move in. That's how you will go from S to R. You can't go from here. You can't. So have you guys understood more or less all of these things that I've tried to explain in this particular video, which is about graphs? If you did, don't forget to like, comment, share, and subscribe to my channel. Bye bye, and have a really, really nice day ahead. Bye.